So what we're going to do first is install Truffle. Installing Truffle uses Node and NPM. And if you don't have Node and NPM installed in your machine, you will first need to install those. Once you have those, however, you can easily install Truffle by running the command through npm. So npm install -g truffle, and the -g says you're going to install it globally. We're going to go ahead and watch that run. And this process takes a second. There you go. It has installed all of the dependencies for Truffle, and now we should have Truffle on our machine. So what we need to do first is create the example project directory. So now example project exists. I'm going to navigate to the example project directory within the terminal, and then I'm going to run truffle init. And what truffle init is going to do is it's going to give me a basic Truffle application with related files and folders in order to make Truffle work. So the folder structure that it gave us are app, contracts, environments, test, and truffle.json. Now that we have our initial Truffle application, the first thing I'm going to do is I'm going to add this application to my editor. Perfect. File, add project folder, and I'm going to add example project. So now we should see this project. And notice we have the directories that we had before: app, contracts, environments, and test. First thing I'm going to do when looking at the example project is look at example.sol. This is a contract that doesn't do anything. For sake of the video, I'm going to make some very simple things. One, it will be uint public value, and value equals 5. So value has a default starting of 5, default value of 5, and then we're going to add a new function that allows us to set the value, and there we go. So the structure of this, we have a value here. Since it's public, it will create a function to allow us to get that value. The default value of this contract is 5, and we have a function that allows us to change the value at will. So that is the contract we'll be working with. What we need to do next is compile the contract. So back to where we were, we're going to run truffle compile. And what that's going to do is it's going to try to compile the contract, and you'll notice that on line 12 we have an error, function variable struct or modifier declaration expected, says compilation failed. So what truffle compile really does is it creates some artifacts, some compilation artifacts here, which we will get to later on. Compiling is done. The next thing we might want to do is deploy the contracts to the network. In order to deploy them, we have to talk a bit about configuration. This file here, truffle.json, is the main configuration file. We have a couple different main configuration pieces here. The one we're going to look at for deployment is this one here that says deploy. What this says is when you run truffle deploy this contract to the network, and this name needs to match up with the contract in the contracts directory. Note that there is no .sol. There is no file extension here. So when we say truffle deploy will automatically compile the contracts for you, again, to make sure that you're deploying the latest version of the contract. And then it will deploy it to the network, and you'll notice that we sent it to the network. There were no errors, so this deployment worked. The next portion is testing our contracts, and that would be the test directory. Currently, we have a file called example.js, which has a test related to the contract. Let's go ahead and delete the default test that's there, and we're going to write something new. Note that this function here is a special function provided by Truffle for its testing environment. However, the backend for testing in Truffle is Mocha and Chai. So you can look up Mocha and Chai tests and documentation to figure out how to write these specifically. We're going to write a couple tests, should get the value. So know that example started at 5, and when the example contract's deployed to the network, it should have a starting value of 5. So actually, let's should have a starting value of 5. What Truffle is going to do when you run your tests is it's going to deploy them again. It's going to deploy your contracts again in such a way that they will be used for each of the tests that we write, and it'll make sure that your tests don't erroneously conflict with each other. Now, in our tests, Truffle will automatically give our tests a representation of the contracts that it deploys to the network. This representation, the object that it uses has the exact same name as the contract itself. So I can just start using the example contract. Example represents the type of contract itself, but in its uppercase form does not represent a specific contract on the network. It just represents that contract in general. If we needed to represent a specific contract, we should get an instance of this representation. And the way that we do that is there are a couple of ways. The way that we're going to do it this time is use the one that we already deployed. So there's a special function that says example.deployed, and what we're going to do is get a version of the example that represents the example contract at a specific place on the blockchain. So now that we have that, we can start interacting with that contract. To get the default value of 5, note that this Solidity contract not only has this value here, but creates a function for us that will allow us to get the value since this is public. So what we can do is say example.value, and note that this is a bit technical, but we want to use the call function to get a value because we don't want to change the state of the network, we just want to read data from it. So .call is free and doesn't cost anything for a transaction. So if we're just reading data, this is the way we want to go. So we'll call, and then should get a value for value. And what we want to do here is assert equal 5 value. Assert value is 5, and we will give the error message. If this assertion fails, we will say default value was not set to 5. One thing to note here is that integers on the Ethereum network can be larger than what can be represented in JavaScript, which means that this value we're getting back is not a JavaScript integer. It's actually an object called big integer, represent integers larger than JavaScript's maximum. So what we need to do if we want to compare this JavaScript integer of 5 to a non-JavaScript integer, to a big integer, we have to call value of, and this will actually turn its value into a JavaScript integer. And since it's 5, it's less than the max, we're fine. So we should do this assertion. Just for housekeeping, after it passes assertion, let's call the done function, and if we have an error, let's also send that to the done function. The done function is linked to the testing framework, and if it receives an error, it will display that error on screen. Now we're going to write one more test. This test up here allowed us to read the value. What we're going to do is set the value. So it should set the value correctly. And this one is similar, taking a done function. And then what we need to do is set the value first. So to set the value, we need to call the set value function. So example.setValue. And note this is slightly different. We are actually wanting to change the state of the network here. So we're not going to use .call. We're just going to use the function itself. And this function takes one parameter. So we're going to pass one parameter. We're going to pass a value of 24. And after that has been processed by the network, then we are going to respond here. Now, when you call a function that changes the state of the network, you can't get a return value. So we're not getting a return value here like we did here. In order to make sure that we correctly set the value to 24, we're going to get the value a lot like we did up in this previous test. So I'm actually going to copy and paste this. Since we're doing promises, though, this call function returns a promise. And what you can do is, instead of having callback after callback after callback, promises let you do these things in line. So we're going to return this, which returns a promise, and then continue the execution here. And now we should, in this case, we should get a value. And what we want to do is exactly the same as what we did before. We're going to copy this line here. And in this case, we are making sure it was set to 24, which it was up here, and value was not set correctly. So we have two tests in this example.js file. It's named example.js because it represents example.solidity. It represents that contract. However, you are not required to, there's no naming convention on these JavaScript files. They're just for your own use. So now that we're back up here, we're going to run those tests. So run Truffle test. And if we did everything correctly, it should run. So Truffle test compiles the contracts and then it runs them. This should not take this long. So it looks like I have run into an issue. And that issue was that housekeeping that we forgot. And this is actually a good example to have. So when this assertion's done, I need to call the done function. And again, if there's an error, let's also pass that to the done function. So run this test again, and we'll notice that everything passed, which is great. So the next thing to talk about is developing a front end for your application. The front end is mostly up to you as far as how you want to organize these files. You don't have to have an images directory. You don't have to have a JavaScript directory. You don't have to have a style sheets directory. This is just a default convention given for you. Let me even go further. You don't even have to use Truffle's build process. However, it does, if you do use Truffle's build process, then it gives you some features that you'd otherwise have to do on your own. Truffle's build process is a simple one. You have targets, and you say which files should go into making up those targets. So if you look at this build configuration here, this first one says that just take index.html and that will make up one target. So one file, one target, there's no change. This one's exactly the same, actually. This one's saying take this file, JavaScript's app.js, and create an app.js from it. The reason it's in a array like this is so you can add other JavaScript files, JavaScripts, something.js. For instance, if something.js existed, it would take app.js and something.js and concatenate them together to then create app.js. Same thing with style sheets, same app.css. And this one is a directory. We're saying copy all the images from the images directory into an images directory in the build file. So what happens during building is that all of these files get processed. These files on the right side get processed to create the files on the left. And we're going to run Truffle build just to give you an idea. And it said it completed without errors. So what this does is it takes the built files and sticks them within your environment. And now the default environment for any command is development. You will need to set, if you want to use a different environment, you have to set that yourself. However, what was created is this. We have app.css. That was created here. The file was empty. We have app.js, which was created here. We have an images directory, which represents the image directory we had, and we have index.html. So notice these match up entirely or exactly with the targets on the left side. Now let's go on to developing with Truffle. To make development easy, we are going to call Truffle serve. And what Truffle serve does is it will automatically build our app and serve it on port 8080. So if we go to localhost 8080, this is the app that's created. And notice that we're given this default text here. So one of the things that Truffle serve does is that while you make changes in your app directory, it will go ahead and rebuild your app. So for instance, I have JavaScript's app.js. I should see an hello from Truffle string. If I look in the console, hello from Truffle, there it is. Don't ignore this favicon. But what if I wanted to say hello from my dApp and hit save? Once I hit save, you'll notice that it automatically rebuilds. And if I were to refresh the page, I get hello from my dApp. Your contract objects are automatically available to you. So the ones that we used in the testing environment are the exact same objects we'll use here. And so you can easily program for your dApp. For instance, we're going to get an example like we did before, example.deployed. We're going to use the deployed version. And then example, we have a example object that represents a contract at this address. And then I can say something like example.setValue. And that runs exactly the same. Quick thing to note that as you make changes to anything within the app directory, your Truffle will rebuild the file for you. So even if I make a comment, it will still rebuild your whole application so that it can serve it to you through 8080. All right, so from here, you should be able to create a new Truffle project, edit the contracts, compile the contracts, deploy the contracts to your network of choice, and write tests for the contracts, as well as build a front end for your application. Last thing we should talk about is how Truffle talks to the network. For this whole example, we have been using something called ethersim to represent our Ethereum network. Ethersim is a blockchain on its... ethersim is a blockchain in memory. It allows you to write and deploy contracts very fast, but it doesn't actually talk to any network. So it's all about development and speeding up your development process. If you want to talk to the real network and deploy contracts to the real network with Truffle, you'll need to install Ethereum clients out there, for instance, Go Ethereum or CPP Ethereum, and then you need to point Truffle at those Ethereum clients, and that is through this RPC configuration here. This basically tells Truffle to point at the Ethereum client at localhost and at port 8545. My experience, I like to use port 8545 for all of my Ethereum clients so that when I switch between networks, I don't have to change any Truffle configuration. However, if you do have different environments where you do want to save their configuration, you can do that through the config files related to each environment. So these are your default environments that you're given: development, production, staging, test. These are recommended environment names. However, you can change them as much as you want. And each environment has a configuration file. Now, the default configuration does nothing, but anything you put in here will override what's in truffle.json. So, for instance, when you're using the development environment, and if you have a special RPC for development, you could put the RPC configuration in here, or for instance, in the production config, the same deal. Staging, test, or maybe perhaps you have you want to rename one of these to Morden to be the Morden testnet. And to use a different environment, all you need to do is use the -e parameter after each command that you type. So if you want to actually deploy your contracts to production, for instance, you might say -e production. Your environments will likely point to a different network, and so it will go and save versions of your contracts that represent what you have deployed to those networks, and can upload these to your repositories and make sure these are managed on an environment basis. So this should help management of the many versions of your DApp across test nets and live networks and private networks. It should make that much easier. My name is Tim Coulter. Feel free to ask me any questions on the Gitter page, which is at the top of the README. And thank you for using Truffle, and good luck.